Hi, you guys. We're going to continue factoring and we're going to talk about special cases. So, you want your notebooks out and being ready to copy and take notes. So, we're going to start with difference of squares. If we identify a squared minus b squared as a pattern, the answer is a plus b, a minus b, is what that can factor to. So, if we look at these, we want to see if this is, I'm going to write it at the top, a squared minus b squared equals a plus b, a minus b. We want to think of this, if we can write this as something squared minus something squared. We can write 36 squared as 6 squared. So that's going to be our a value. And we can write x squared as x. So b equals x and a equals 6. Now I'm going to put it into this equation of a plus b, a minus b. Ooh, I made a mistake. A minus b. So you guys look at the next one and see if it is the pattern of something squared minus something squared. So we can write this as something squared minus something squared. This would be 5, and that would be v. So a equals v, b equals 5. So I do the a plus b, a minus b. If we look at these, I can still write this as something squared minus something squared. So I can use this equation. 4 times 4 is 2, or 2 times 2 is 4. 9 times 9 is 81. And the x times the x is x squared. So a equals 2, b equals 9x. So I can do a plus b, a minus b. Go ahead and write this as something squared minus something squared. Pause it and then see if you can finish the same steps we did for that example. So you'd have 2 and 3v. And then we do our a plus b, a minus b. I can keep continuing this. It just may become a little bit more work to identify our a and our b. 5 is b. X times z squared would give us x squared, z squared. So we do a plus b, a minus b. Here we do something squared minus something squared. Go ahead, pause your screen, do this one on your own. So this is 2x, 5z. So a equals 2x, b equals 5z. A plus b, a minus b. I can still do these ones as well. I see that I have a greatest common factor of a v squared, or 4v squared. So I'm going to pull that out first. So I get 25 minus v squared. And I can write this as something squared minus something squared. A equals 5, B equals V. A minus A plus B, A minus B. I want you to think about what we can pull out here. Think about the greatest common factor here would be a 4, and I get 4 minus V squared, same as 2 squared minus V squared. So A equals 2 and B equals V. A plus B, A minus B. So I see the greatest common factor I have is a W to the 4th. So I get 16 minus Y to the 4th. And that's 4 squared minus Y squared squared. So A equals 4, B equals Y squared. So W to the 4th, A minus A plus B, A minus B. And then I can actually do an A squared minus B squared again here. So A is 2 and B is Y, so that'd be A plus B, A minus B. And I still have the W to the 4th, 4 plus Y squared. So the last little topic for this that we need to talk about is sum and difference of cubes. So we just did difference of squares. We have an a squared minus b squared situation. We learned what that formula was. Now we're learning if we have a to the cube plus b to the cube or a to the cube minus b to the cube. This is a formula that we're going to use. The signs are what changes. So we see it's negative, positive, 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 negative, positive. A way to remember that is SOAP. SOAP stands for the same sign. So this is going to be the same as whatever that is. Opposite. This is the opposite of the original sign. Always positive. And this one's always positive. So we have same, opposite, always positive. So we're going to start applying these in the next slides. So here's the formula. First thing we need to identify is we know there's a plus in between. But can we write this as something cubed plus or minus something cubed? So I know this is x. This is 4, so my a equals 4. My b equals x, and now I'm going to plug it into the first equation. So I have a plus b, a squared minus ab plus b squared. Everywhere I see an a, I'm going to put a 4. Everywhere I see an x, I'm going to put everywhere I see a b, I'm going to put an x. I'm just going to rewrite that a little nicer. We want to go ahead and see if we can write this as something cubed plus or minus something cubed. We know that 4 times 4 times 4 is 64. 3 times 3 times 3 is 27. Y times y times y is y to the 3rd. So my a is 4. My b is 3y. I use a subtraction sign. So this is the difference of cubes. I'm just rewriting the formula. If you don't need to do that, you don't need to do that. Everywhere I see an A, I'm going to put a 4. Everywhere I see a B, I'm going to put a 3y. And now I can write that nicer. And that's what we should end up with there. This last one I want you guys to do by yourself. So go ahead and pause the screen, do it by yourself. Use one of these two formulas. We'd end up with 2 and a y. Same sign. Opposite sign. Always positive sign. And then I can just write that nicer. We'd actually probably write that as 2y. Okay, so you guys should still have your factoring chart, so you want to have that out and be looking at that. We're going to add to our 2 terms column. 2 terms, we're going to use sums of cubes or difference of cubes and then difference of squares. So we have a squared minus b squared equals a plus b, a minus b. And then we'd want to add there that. And we're going to go ahead and do these two. I see that this is a difference of cubes. So I'm going to use my difference of cubes formula. Same. Opposite. Always positive. And then we can write that nicer. And then this is difference of cubes. Guys, I'm going crazy. And then we just have a plus b, a minus b. Good job. That's skill 12, and you guys should be done with your factoring tree now.